Electrical code requirements specify clearance around electrical panels. According to the National Electrical Code, there must be 4 feet or 1.2 meters of clear working space in front of the panel. This measurement extends from the front edge of the panel to any obstructions. Furthermore, the code requires 3 feet or 0.9 meters of clear space from the top of the panel to any overhead obstructions. Finally, there should be 18 inches or 45 centimeters on each side of the panel to any walls or other obstructions. These clearances are crucial for safety and accessibility during maintenance and repairs. The grandfathering principle in the National Electrical Code allows existing installations that do not meet current code requirements to remain in place, provided they are not modified and are safe. This means that if an existing electrical installation was compliant with the code at the time of its installation, it may not need to be upgraded to meet current code requirements unless modifications are made. However, it is important to note that grandfathering does not apply to new installations or major modifications of existing installations. When a major modification is planned, the entire installation must be brought up to current code standards. An existing electrical panel located over a built-in bookcase and recessed behind sliding doors does not meet the current code requirements for clearance around panels. Therefore, the grandfathering principle may not apply if the customer replaces a 60-amp panel with a 100-amp panel, as this is considered a major modification. It is recommended to consult with a qualified electrician to assess the situation and determine the best course of action. The electrician may be able to suggest solutions that meet code requirements while preserving the existing structure. Here are some possible solutions. Firstly, removing the bookshelf to provide the required clearance. This would involve physically detaching the bookshelf from the wall and relocating it to another area of the house. This option may be the most straightforward in terms of meeting code requirements, but it may also be the most disruptive to the customer's home. Secondly, modifying the bookshelf to create an opening that provides the required clearance. This could involve cutting into the bookshelf to create a recess that allows for the required clearance around the electrical panel. This option may be less disruptive than removing the bookshelf entirely, but it may also be more complex and require specialized tools and skills. Thirdly, installing a subpanel in a more accessible location and using the existing panel as a secondary distribution panel. This would involve installing a new electrical panel in a location that meets code requirements and then running wiring from the existing panel to the new panel. This option may be the most expensive, but it may also be the most convenient for the customer, as it would allow them to keep the existing bookshelf in place. In conclusion, the existing situation may not be grandfathered if the customer replaces the 60-amp panel with a 100-amp panel. It is recommended to consult with a qualified electrician to determine the best solution that meets code requirements and the customer's needs. When assessing an electrical panel upgrade, several factors beyond the basic clearance requirements need consideration. Firstly, the load calculation for the residence should be re-evaluated to ensure the new 100-amp panel is adequate for the existing and anticipated electrical loads. This calculation involves adding up the amperage demands of all the circuits in the house, including lighting, appliances, and other electrical devices. Secondly, the service entrance conductors, which are the wires that bring electricity from the utility company to the main panel, must be sized appropriately for the new 100-amp panel. If the existing service entrance conductors are not large enough, they will need to be replaced to prevent overheating and potential fire hazards. Thirdly, the grounding and bonding system must be properly installed and maintained to ensure electrical safety. This system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding electrode conductor, which connects the grounding system to the earth, must be of the correct size and material. Fourthly, arc fault circuit interrupters or SIs and ground fault circuit interrupters or GFCIs are required in many areas of the home to protect against electrical fires and shocks. SIs are designed to detect arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. GFCIs are designed to detect ground faults, which are electrical leakage currents that can occur when a person comes into contact with a live wire and a grounded object. The National Electrical Code, Specifically, Article 110.26 addresses the workspace requirements around electrical equipment operating at 600 volts nominal or less. This section emphasizes the importance of providing sufficient space for personnel to safely operate and maintain the equipment. The depth of the working space in front of the electrical panel depends on the voltage of the equipment and the conditions present in the workspace. Condition 1 applies when there are exposed live parts on one side of the workspace and no grounded parts or grounded parts that are insulated on the other side. Condition 2 applies when there are exposed live parts on one side of the workspace and grounded parts on the other side. Condition 3 applies when there are exposed live parts on both sides of the workspace. For a 100 amp panel operating at 120/240 volts, the required depth of the working space is typically 3 feet or 0.9 meters for Condition 1 and Condition 2, and 4 feet or 1.2 meters for Condition 3. The width of the working space must be at least 30 inches or 76 centimeters, or the width of the equipment, whichever is greater. This ensures that there is enough room for a person to stand and work safely in front of the panel. The height of the working space must be at least 6 feet 6 inches or 2 meters, or the height of the equipment, whichever is greater. This provides adequate headroom for personnel to avoid bumping their heads on overhead obstructions. In addition to the workspace requirements, the National Electrical Code also addresses the requirements for access to electrical equipment. Section 110.26 states that access and working space shall be provided and maintained about all electrical equipment to permit ready and safe operation and maintenance of such equipment. This means that the electrical panel must be readily accessible and free from obstructions that could hinder access or make it difficult to work on. The presence of the built-in bookcase and sliding doors in the described scenario clearly violates these access requirements. The bookcase obstructs the working space in front of the panel, and the sliding doors impede access to the panel. In addition to the National Electrical Code, local electrical codes and regulations may also apply to the electrical panel upgrade. It is important to check with the local building department or electrical inspector to determine if there are any additional requirements that must be met. Local codes may have more stringent requirements than the National Electrical Code, or they may address specific issues that are not covered by the National Electrical Code. For example, some local codes may require that all new electrical installations be inspected by a qualified electrical inspector before they are energized. When considering the solutions for meeting code requirements while preserving the existing structure, it is important to weigh the costs and benefits of each option. Removing the bookshelf may be the most straightforward solution, but it may also be the most expensive and disruptive. Modifying the bookshelf may be less expensive and disruptive, but it may also be more complex and require specialized tools and skills. Installing a subpanel may be the most convenient solution, but it may also be the most expensive. The decision of which solution to choose should be based on a careful consideration of the customer's needs, budget, and preferences. It is also important to obtain the necessary permits and inspections before starting any electrical work. Electrical work can be dangerous, and it is important to ensure that it is done safely and in accordance with all applicable codes and regulations. Failure to obtain permits and inspections can result in fines, penalties, and even legal action. The choice of circuit breakers for the new 100 amp panel should be based on the type and size of the circuits being protected. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When an overload or short circuit occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment. There are several different types of circuit breakers available, including standard circuit breakers, ground fault circuit interrupters or GFCIs, and arc fault circuit interrupters or RFCIs. Standard circuit breakers are used to protect general-purpose circuits, such as lighting and appliance circuits. GFCIs are used to protect circuits in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor outlets. RFCIs are used to protect circuits in areas where there is a high risk of electrical fires, such as bedrooms and living rooms. The size of the circuit breaker should be matched to the size of the wiring being protected. The National Electrical Code specifies the maximum size of the circuit breaker that can be used with different sizes of wire. Using a circuit breaker that is too large for the wire can result in the wire overheating and potentially causing a fire. In addition to the circuit breakers, the electrical panel should also be equipped with a main disconnect switch. The main disconnect switch is used to shut off all power to the panel in case of an emergency. The main disconnect switch should be located in an easily accessible location, such as near the entrance to the room where the panel is located. When installing the new 100 amp panel, it is important to follow all manufacturer's instructions and safety precautions. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on it, and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. A qualified electrician has the training and experience necessary to perform electrical work safely and in accordance with all applicable codes and regulations. The electrician should also be able to provide you with a certificate of compliance, which is a document that certifies that the electrical work has been done in accordance with all applicable codes and regulations. Upgrading an electrical panel involves several considerations that extend beyond simply replacing the existing panel with a larger one. Firstly, a thorough assessment of the existing electrical system is essential. This includes inspecting the wiring, grounding, and bonding to ensure they are in good condition and meet current code requirements. If any deficiencies are found, they must be corrected before the new panel is installed. Secondly, a load calculation must be performed to determine the actual electrical demand of the residence. This calculation takes into account all the electrical loads in the house, including lighting, appliances, heating, and cooling systems. The load calculation will determine the appropriate size of the new panel and the service entrance conductors. Thirdly, the new panel must be properly grounded and bonded to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Fourthly, surge protection should be considered to protect sensitive electronic equipment from voltage spikes. Surge protection devices, or SPD, can be installed at the main panel to protect the entire electrical system. Finally, arc fault circuit interrupters, or SIs, and ground fault circuit interrupters, or GFCIs, should be installed as required by code to protect against electrical fires and shocks. SIs are designed to detect arc faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. GFCIs are designed to detect ground faults, which are electrical leakage currents that can occur when a person comes into contact with a live wire and a grounded object. When choosing a qualified electrician to perform the electrical panel upgrade, it is important to consider their experience, qualifications, and insurance coverage. The electrician should be licensed and insured, and they should have a proven track record of performing electrical work safely and in accordance with all applicable codes and regulations. It is also a good idea to get multiple bids from different electricians before making a decision. When evaluating the bids, be sure to compare the scope of work, the materials being used, and the price. Be wary of bids that are significantly lower than the others, as this may indicate that the electrician is cutting corners or using substandard materials. In addition to the technical aspects of the electrical panel upgrade, it is also important to consider the aesthetic impact of the work. The new panel should be installed in a location that is both accessible and aesthetically pleasing. The wiring should be neatly installed and concealed whenever possible. The finished product should be a safe, reliable, and visually appealing electrical system. Remember that tampering with electrical systems can be dangerous and should only be performed by qualified professionals. Safety should always be the top priority when working with electricity.